Good afternoon, everybody. I want to thank you for attending this online session. My name is Bob Boule. I'm with StarWind Software. I'm one of the senior solution engineers here with the company. Today we're going to be talking about shared storage for the small and medium business, focusing primarily on the StarWind Enterprise Edition. Just to give you some background, StarWind Software, an Iscuzzy software provider, offers a number of different editions of their product. And today, we're going to focus on mainly the non-high availability editions. So mirror and replication, snapshot CDP, thin provisioning, all the things that you get with what we call the enterprise edition of the product, and really bring you through, how those features can be leveraged, what are some of the things that you can do with those features to make sure that you protect your data, provide yourself with things like rollback capabilities, and be able to utilize storage as efficiently as possible. Just to give you a brief overview of the agenda for today, we're going to start off with an overview of SAN technology. For those of you that have heard me speak in the past, I always like to start with this just to sort of level set. We're going to talk a little bit about SAN versus direct attached storage, and some of the benefits of a more centralized storage model and centralized storage management versus the direct attached approach, which we're all familiar with. We'll talk a little bit about Iscuzzy and why Iscuzzy, why you should consider Iscuzzy for your implementation, and specifically around Iscuzzy software. Some of the application advantages of shared storage. So this is really where we're going to start talking about, creating application-based clusters or virtualization clusters, and really where the role that shared storage plays in that, and the focus on, again, data protection, using some of the data protection features of StarWind to go ahead and allow you to put a scenario together where you can either use continuous data protection or mirroring or thin provisioning or snapshotting to go ahead and make sure you've got the ability to recover from a problem, or you're never putting your company's data at risk by giving yourself rollback capability. So all of this we're going to get into as we transition into the live demo. So I like to split these up. The first part of this is going to obviously be a PowerPoint presentation, and then we're going to actually get into the product itself, and we're actually going to do a demo. We're going to go into the lab and do a few things, and I'll show you, sort of how StarWind works, walk you through the user interface, and really give you a sense for how to go ahead and start setting up your Iscuzzy SAN. And then we're going to wrap up with Q&A. Now, the Q&A is something that, we'll try and get to as many live questions as we can. And basically, if I don't get to your question, and it's important that you type those questions directly into the Q&A section of the GoToWebinar interface, because that records the question for me as well. So in the event that I don't get to it, we will make sure you get an answer to any question that you ask. So if it's not live, we'll follow up with you after the session. I am also recording the session, so you'll also get a note, with the ability to access the recording of this. So if you're interested, or if a colleague wasn't able to attend, you'll certainly be able to follow up and make sure they get a copy of this as well. With that said, let me go ahead and jump right in. I always like to start off with, sort of an overview of some of the more traditional SAN technology. In that, we're talking about Fibre Channel. And, the Fibre Channel SAN is something that has been around for a while, through companies like EMC. Very, very rock-solid technology. This is a technology that, obviously, you're going to see in a lot of larger enterprises. You may see it in some smaller markets. Certainly, it's a technology that's been around a while, is very, very mature from that perspective, and is going to deliver reliability and performance. The issue is, and the reason why protocols like Iscuzzy have gained in popularity, is really focused around the cost that's associated with something like this. And so, obviously, when we start talking about the proprietary nature of what's needed to install something like this, the costs start to rack up, not just the upfront cost, but also the TCO. So when you start talking about total cost of ownership and the ongoing maintenance of a system like this, and the training that's involved, and the ability or the need to as you backfill positions in IT, really, chip up what you have to pay folks because you need some of these specialized skills. It's something where, you sort of get into this and you think about just the upfront cost, but it's the ongoing cost that is also a factor here. And so when we look at this, we start talking about, proprietary host bus adapters in all of the host servers. So this is their connectivity to the storage through these host bus adapters. With Fibre Channel, these are a proprietary piece of equipment. We start looking at Fibre Channel switching technology, and again, we're talking about, switching technology dedicated to the storage, so a proprietary, network fabric that is going to need to be implemented here. Again, no downside to any of this, just simply cost prohibitive for a lot of us. Then we look at the Fibre Channel SAN, and again, we're talking about fast, reliable, high performance, but very, very expensive. And so again, I think that the idea behind this is not to, sort of discourage anyone from Fibre Channel. It's just pointing out that this is obviously a technology where, the cost hurdles generally put, for something like this will put shared storage out of a lot of our reaches. And so we certainly don't want to do that, because shared storage and the concept of shared storage and some of the things you can do in a shared storage model are just too important to not consider or not be able to implement it based on the fact that, the system you might be looking at is just simply too expensive. So with that, we move on to the Iscuzzy SAN. Now, Iscuzzy obviously is a much different from the perspective that you're going to be able to leverage a lot of the commodity hardware. So, Iscuzzy, we're talking about utilizing the IP protocol. A lot of times you'll hear it referred to as an IP SAN, where we're going to be actually utilizing standard networking. So, gigabit backbone, gigabit NICs. There is the possibility of implementing, say, an Iscuzzy HBA. However, it's not always necessary. You can certainly use the standard gigabit NICs, and with the offloading capabilities in today's network cards, you can do that without having to worry too much about impacting the resource utilization of your application servers. So again, you're talking about, the standard, gigabit networking, Cat 5e, Cat 6 cabling, standard gigabit switch, that certainly is going to make this a much simpler install and a much easier on the wallet type of implementation. So you're not talking about big dollars from the network on down before you even get to the storage. Now, as we work our way down and we start talking about, from the switch down to the Iscuzzy boxes, what I'm going to talk about a little later on is the beauty of software Iscuzzy and the ability to go ahead and, essentially create your own storage box based on, your performance needs and giving you the flexibility to go ahead and bring a piece of shared storage in for a budget. But as we move down here, we're talking about, the Iscuzzy boxes. You've got really two main decisions here you can make. You can go with the appliance-based type of Iscuzzy, again, where you can go to a vendor like EMC, you can go to Dell EqualLogic, HP Left Hand, and buy the equipment. So you basically buy a piece of hardware. It's got disk in it. It's basically a storage controller that supports Iscuzzy. They provide you with an interface where you can manage that and parse out those disks. So there's one option. The second option for your storage layer in an Iscuzzy SAN, as I mentioned, is the software approach, where basically, in the case of StarWind, you'd put, the Windows-based OS on top, and then ultimately the StarWind software would be loaded onto that, and then, basically attach the remaining amount of storage, whether it be internal to the box or through an external storage controller, connect that storage up, and then start creating your Iscuzzy targets using our software. And the nice part about this approach, not just the StarWind approach, but just the general software approach to Iscuzzy, is we're going to provide you with a lot of flexibility. So you're really going to get to choose what type of equipment gets used. What is the speed, size, density of the disks, so that you can pick and choose. So maybe you need your low density, fast disk for serving up tier 1 applications, and then you can go ahead and with that mix in some of the more dense, slower disk for backups, archiving, test and dev, or QA, or something along those lines. So a lot of flexibility here in how this SAN is going to be made up by utilizing the software approach to Iscuzzy, which simply isn't available, from the Fibre Channel perspective. So, the commodity-based hardware approach, the ability to go ahead and either choose an appliance or to sort of go down the path of software and build out your own Iscuzzy targets. Now, one of the things I always like to talk about in these sort of sessions is that central storage management versus the direct attached storage. Now, a lot of us will look at this and bypass some of the more fundamental benefits of a central storage approach to skip right down to, I want to create a cluster. I want to be able to enable vMotion. I want to be able to create high availability for my virtual machines. And those are all valid, very important reasons to be looking at shared storage. But I think there are a couple of other items that I always like to mention ahead of time before we get down to that, and that when you consider a SAN implementation, you're really talking about storage consolidation. So you're basically going to, instead of having multiple servers, I don't care if they're physical application servers or virtualization hosts, whatever the case might be, you've got individual servers that are out there with their own little pool of storage in them. And chances are there's some inefficiencies going on there. You're basically putting storage into those boxes based on not what you need today, but what you think you're going to grow into 6 months, a year, 18 months out. And so you've got ultimately disks sitting in those boxes that's spinning but not accomplishing anything. And so when you take a more centralized approach to storage, where you take the bulk of the storage, and it's not necessarily, I'm not advocating maybe going diskless, although that is an option in those servers. At a minimum, the bulk of the storage can be removed from those servers and put into a centralized storage pool so that you can then parse those storage resources out on an as-needed basis to those application servers and, be able to attain a much higher utilization rate of the storage that you have and bring storage that you don't need offline temporarily and then ultimately bring it back online and parse it back out when you need it. So, that central storage approach, really, we're talking about efficiency. We're talking about the ability to go ahead and consolidate the storage that you're utilizing and really cut down on the costs that are associated with storage, because you don't have large pools of unused storage sitting in individual application hosts. The other piece, obviously, is the bulk of what we're going to talk about today, which are the data level protection options. So, a lot of us, are looking at things like nightly backups. And so how do I augment that? So how do I go about, what happens if I take my nightly backup and something happens at 10 o'clock the next morning? Or, what if in a SQL Server environment, I've got 100 databases and I don't want to set up, replication or log shipping for all 100 of these things because it's just simply too many moving parts. You can bring a lot of those functions down to the storage. So you can do things like replicate the storage that's associated with your SQL Server, snapshot the storage that's associated with that data, and ultimately get a level of protection so that you're going to be able to, one, create a scenario where, you can manage to expectations. So if the expectation is that you'll never be more than 15 minutes out of band or 30 minutes out of band, regardless of the disaster, you can accomplish that by using block level or volume-based snapshots as opposed to trying to put more pressure or additional pressure on your application servers to perform some of these data protection tasks. And then obviously as we move down the list here, we get into unlocking enterprise application features. Obviously, they're all the same when it comes to, when we're talking about VMware, Hyper-V, Xen, or shared storage for a cluster, which is going to be the same as a Hyper-V scenario, where we're talking about high availability. We're talking about the ability to go ahead and make sure that you don't have a single point of failure for any given application. For those of you that are virtualizing, the ability to go ahead and load balance across multiple machines, either through, VMware's distributed resource scheduler, where it's going to go ahead and actually move virtual machines around for you, or, be able to use, things like live migration within Hyper-V to go ahead and properly load balance across the multiple Hyper-V servers that you may have in your cluster. So a lot of features become unlocked there, and they become very important as we talk about server consolidation, and we're talking about the impact that a down server can have. Not just, it's not just a single application anymore. Now we're talking about 4, 5, 10, 12 virtual machines representing the bulk of applications that maybe you're running. It's all that much more important to have that shared storage component so that you can continue to take and create some high availability for those virtual machines or some fault tolerance. Now, when we start talking about shared storage, the conversation usually starts off with, okay, I've got, 3 real choices here. I've got Fibre Channel, Iscuzzy, and NAS. So, I'm really, from that perspective, I think the only real choice for a lot of us, and the only real 2 choices for a lot of us, are going to be Fibre Channel or Iscuzzy. And then when we start talking about the costs that are associated with getting involved in even a small-scale Fibre Channel deployment, we tend to gravitate toward Iscuzzy because it's less cost prohibitive. It's going to allow us to go ahead and utilize standards that we've been working with for years. So there's not going to be a lot to learn. There's not going to be a big learning curve. I'm going to be able to put this SAN in place. I'll be able to work with my vendor to get it set up and get it in place in a matter of days rather than weeks. And ultimately get myself in a situation where I can, really move or compress down the cycle of the rollout of my virtualization or my high availability type of scenario, and really get myself in a position where I can start realizing the ROIs around this types of consolidation immediately. I talked a little bit earlier about the software approach to Iscuzzy, and again, I think that you as the potential users of these products, you have a lot of choices. And I think I would submit to you that, the reason I would consider software is just that level of flexibility that you're not going to get with the hardware vendors. The hardware vendors, I can't sit here and say a bad thing about EqualLogic, Left Hand, NetApp, some of the EMC offerings. They're all terrific. The problem is that they tend to lock you in, and you tend to get into a situation where, they're selling you the equipment. They're telling you, here are your 3 flavors or here are your 4 flavors of what you can purchase. And if that doesn't meet your needs, then you're going to have to purchase something in addition to that. Whereas the software approach, you're in complete control of what that hardware makeup looks like. So you're going to be able to decide, geez, I don't need 10 terabytes of, really fast SAS disk. I probably only need 2 terabytes of SAS disk, and the rest of it can be more bulk storage, and I can go out and buy slower, less expensive, higher density drives for the rest. So, we make it a lot easier for you to be able to accomplish that all under a single umbrella. So you basically can go with a single vendor. Each box can look a little different because, as you're going to see here, we're going to virtualize the storage. So each virtual storage device is going to be assigned to a physical storage asset. And so it will leverage the performance of that physical storage asset, but allow you to really go through the process of setting up a scenario where you are in complete control. And I think when we talk about why Iscuzzy, we're talking about that flexibility that the actual protocol gives you, along with the software approach and the flexibility that the software will give you in terms of building this out. And this all boils down to, how do I do this for a reasonable cost? How do I do this without completely blowing my ROI out of the water as it relates to my consolidation efforts? And so, that's where we wrap up with, reliable, fast, and affordable. Now, this is sort of a rather rudimentary diagram, and it's meant to be that because I only want to show a specific scenario here. So, one of the things that I like to talk about when we get into this is, really the simplicity behind this and how this really doesn't have to be very complicated. And so that's what this diagram is meant to show. In this case here, we're talking about, a two-node SQL Server or Exchange cluster. This could very easily be a two-node VMware resource, ESX resource cluster, or a two-node Hyper-V cluster, or a two-node Zen pool. It doesn't really make a difference. The idea behind it is there's a relationship at the application server level. In this case, we've got SQL Server or Exchange, and essentially we've formed a Windows cluster here. And in order to form a Windows cluster, we need some common storage resources. And so, one of the things of the focus of this particular webinar is sort of on some of our non-high availability offerings and some of the how to utilize some of those features in the event that high availability just is not the right thing for you right now, or you simply are not in a position to purchase either that level of license or the hardware needed to support it. So in this case, what I'm showing here is StarWind set up in an active-passive scenario. This is our asynchronous mirroring of data. And so ultimately, your SQL Server or Exchange nodes, or the nodes that are in your cluster here, will ultimately attach via an Iscuzzy initiator to the active storage node. As data is written from this cluster, now immediately when you do this, you meet the requirements for shared storage around setting up a cluster. So immediately now you're in business. You've got the ability to go ahead and set up high availability for your SQL Server or your Exchange or your Hyper-V virtual machines, on and on and on down the list, because you have this piece of shared storage. And what this box looks like is completely up to you. Again, this could be a simple repurposed piece of hardware. You could go to Dell or Supermicro and buy a dual power supply, dual controller box to make sure that you don't wind up with any failures here. But ultimately, what we're in a position to do is offer this up so that you've got this particular piece of shared storage as your active node. As data is written to this active node, it is then replicated down to this passive storage node. So this passive node simply sits there waiting. It receives data from the active storage node. That data, as the blocks are committed here, they're pushed down to the second node of the storage, and ultimately that passive node will act as your warm copy of the data. So what you're ultimately getting here is a scenario where if you were to have a failure at the active storage node level, you could very simply, with minimal downtime, point your initiators at this passive node, and there would be an exact replica of this data down at the passive node. So, again, this is a scenario where, using asynchronous replication, which really defines the fact that, replication data only flows in a single direction. So everything is connecting to this active node, and this passive node remains passive until it's pressed into service. Now, the other nice part about this is you can do this locally, so that you have, say, a scenario where you've got that passive node or that warm copy of your data in the event that you need it. Or you could do this and take this passive storage node and put it out at a DR site. Or if you're setting up shared storage, say in a remote office, you could go ahead and replicate this data back to, say, the home office or the main office or the main data center. So again, a lot of possibilities as it relates to the ability to go ahead and replicate this data. The asynchronous replication is designed to be able to run across, a long, thin pipe, whether it be a VPN or some type of WAN connection or something along those lines. So we give you a lot of flexibility there in how that works. And so you can, again, now we're talking about having an exact replica of your data. So this is really, for the purposes of, disaster recovery and for the purposes of, a potential failure of your primary storage box, this is really a feature that really will come in handy for you. Now, when we start talking about, virtualization, it's a similar scenario, and I always like to show a couple of different examples, in this case, VMware. Again, we're talking about the same thing. So we're talking about a setup here at the shared storage level, which may include either mirroring here, or it may include these boxes acting independently, maybe with snapshot enabled volumes. Maybe one box is serving up VMs for the virtual machines. The other box is serving up volumes directly to those VMs to act as repositories for data. It's very common to see customers go through the process of using, say, a basic image file device or a basic, virtual storage device to serve up to their ESX host and create their virtual machines, and then create raw device mappings within those VMs to then go ahead and create snapshot-enabled volumes to actually protect the data within those virtual machines. So again, a lot of possibilities exist here. The other option, obviously, that I always like to mention is the ability to do things like thin provisioning. So, when it comes to things like virtualization, you're going to have a couple of different options. Do you want to thin provision, at the virtualization layer? So VMware obviously is going to give you the ability to go ahead and thin provision a VM. Or do you want to go ahead and thin provision at the storage layer? There are a lot of benefits to going in either direction. I tend to tell people to stay away from trying to do both. Don't get greedy. You're generally going to pick one or the other. And certainly, if somebody's interested in talking a little bit more about that, just let me know via the Q&A section there, and we'll go ahead and reach out to you. But ultimately, as you can see here, I've got a number of different configurations that I can put into play here when it comes to setting up my storage to support whether it be basically the virtualization model or the sort of standard application clustering model. So again, very, very straightforward from that perspective. Now, the next thing I want to do is I want to bop over to a live demo. And so in this case here, what we're going to do is talk a little bit more about how the setup works and get into a little bit more detail about some of the features that are associated with the StarWind product. So as we go through this, I'm going to bring you through each feature and sort of how it works and sort of where it might be applicable as it relates to some of the non-HA stuff. So as I had indicated earlier, the basic setup behind StarWind is pretty straightforward. We're talking about, going through a process of creating a Windows box, so basically taking that and maybe creating a small RAID 1 set within that box to install your operating system, and to go ahead and plug in StarWind or put StarWind right on that server, and then configure the remaining storage either internal to that server or maybe if you've got it connected to an external storage device, present that storage to Windows, configure the RAID sets, present those to Windows. Those will act as physical platforms for our virtual storage devices. As you're going to see, I'm going to walk through here and start to create these. Now, what you're looking at here is the StarWind Management Console. This is sort of the epicenter of StarWind. And so, one of the things that's nice about this is the StarWind installer allows you to do a couple of different things. One, install just the Iscuzzy service, or install just the management console, which again makes it very, very easy to go through it and actually manage this remotely. So you don't have to, be remoting into each one of the SANs to go ahead and manage it. As you can see here, I've got a handful of boxes that I'm working with, from the storage perspective, and we're going to focus on these two here. Now, as you can see, I've already got a handful of targets that I've created, and Iscuzzy targets that I've created here. But once you've got all this set and done, and your networking is right and everything looks good, you're then in a position where you can go ahead and start creating targets. That's as simple as going ahead and clicking on the Add a Target button. Now, everything that's done in StarWind is really wizard-driven, so it's going to make it nice and simple to really get to an answer pretty fast, or get to a situation where you're up and running pretty fast. So, I've clicked on the Add a Target button, and it's going to go through and ask me a series of questions. The first is, what do I want to use for a target alias? We'll call this 4. Now, the next thing it's going to do is it's going to ask me what type of storage media do I want to use in conjunction with this Iscuzzy target. Now, the majority of our customers that are going to come to us are looking to create hard drive or hard disk-based targets. So it's pretty much a no-brainer at that point in terms of which one they're going to select. However, we do offer, as part of our product, a couple of very, very handy utilities, almost like this is sort of the Swiss Army knife approach to Iscuzzy, where we allow you to go ahead and use things like an optical drive. So if you want to take a CD or a DVD burner or a Blu-ray burner, or you want to mount an ISO image and allow it to be connected to via an Iscuzzy initiator, you can do that here. We also offer you the ability to do things like take a physical tape device and pass it through as an Iscuzzy target. So for backup purposes, if you want to leverage a tape device that is on a box, but you want to be able to back up data that's sitting somewhere else, you can simply go ahead and pass through that and then create the Iscuzzy, basically the Iscuzzy pass-through, so they can connect to the device through the Iscuzzy initiator. We also offer the same thing on a virtual basis. So virtual tape array, where basically you can create disk-based Iscuzzy LUNs and present those disk-based LUNs to your backup device or your backup server as a tape drive. So if for those of you that are already using a tape scheme, you could basically make a transition from tape over to disk and continue to have your backup server see this as tape. Now, for the purposes of today, we're going to go ahead and select hard disk and dig a little deeper here. Now, you've got a handful of different options here when it comes to creating a disk-based, Iscuzzy target. The first is the physical target. Now, as I mentioned earlier, one of the things you're doing in preparation for this is you're basically taking a server and you're basically, installing an OS on it, basically formatting and, creating these RAID sets and presenting them to Windows, whether it be one large RAID set or several smaller RAID sets. Those RAID sets are now going to serve as the basis for your Iscuzzy targets. One of the options you have here is the physical pass-through option, where you can choose one of those RAID sets and simply pass it through as an Iscuzzy target. You don't get any of the data protection features that way, but if you'd rather not, create multiple virtual targets, you just want to create one large target, this is certainly an option for you. Now, the other option you have here out of the two is the virtual storage device. Now, what the virtual storage device is going to do for you is basically bring you through a scenario where you're going to be able to create a pool of storage that's going to be basically a file or a series of files. And that series or file or series of files will be assigned to a physical storage asset within this box. So you'll choose basically which RAID set you want this thing to live on. And the nice part about this is this allows you to go ahead and split up maybe an expensive piece of storage to be able to go ahead and leverage it across multiple applications. So, the storage virtualization piece also provides a lot of flexibility in terms of, now if you need to, let's say, move a piece of storage that's generating a very high number of IOPS, you need to move it off there onto another piece of storage. You could simply load StarWind on the second box, take the storage down, copy it over to the second box and remount it. So a lot of flexibility from the virtualization perspective. Now on the virtualization side, we offer two main options. We offer a basic virtual, which I'm actually going to walk you through creating here in just a minute. And then we offer some advanced virtual options. Now for those of you that are interested in sort of the non-high availability, we'll focus here on the RAID 1 mirror device and the snapshot-enabled volume. The RAID 1 mirror device, or what's more commonly referred to as asynchronous replication, is a replication option where you have, just as that diagram I've reviewed earlier outlines, you have an active passive array. So you're in a situation where you've got data being written to StarWind box A, and that device is then taking that data and mirroring it down to StarWind box B, which is the passive node. This can be created, and again, the virtual storage devices could be assigned to any physical storage asset in the storage box itself. So it makes it very easy to go ahead and create this, and then down the road, if you have to sort of move things around, you certainly can do that. Then there's the snapshot or continuous data protection device. This is also our thin provision volume. The snapshot-enabled volume works just like you might imagine. With some of the file-based snapshotting technology that's out there where they're going to capture, a point in time. we do the exact same thing, only we're doing it at the block level. So we're basically saying, all right, every 30 minutes or every 2 hours, basically user's choice in terms of how often this happens, I want to capture a snapshot of the data, and I want to evaluate it for changed blocks. And this is really where this level snapshotting gets much more efficient, in that we're just creating a snapshot based on those changed blocks. And we're creating a journal or restore point based on that. Once we've done that, we're then in a situation where we now have a restore point or a rollback point for that volume. And the difference between the two, the restore point, what we call a restore point, basically what it allows you to do is it allows you to go ahead and take that volume or that snapshot of that volume and mount it as a read-only device, at which point you can then go ahead and copy or recover individual files that are in the exact same state they were in at the point in time that that snapshot was taken. So again, a very powerful feature there in that you're going to be able to go back 20 minutes, an hour, 2 hours, and grab a file that's that's in a state that it was in 2 hours ago. If there's a problem with something, if something goes corrupt or something is introduced that doesn't belong there. The other piece there is the rollback point. So the rollback point means that what I can do is I can simply choose to recreate the entire volume based on that particular point in time. And then once I've done that, just remount the Iscuzzy target. So if something happens and an entire volume is destroyed, data is erased, there's a virus that's introduced, or you just have massive rampant corruption where you simply cannot address the situation with a single scenario, you then are in a situation where you can basically roll that volume back. So you can pick that point in time. StarWind will recreate the volume as it lived 15 minutes ago, 2 hours ago, an hour and a half ago, and then allow you to remount that as an Iscuzzy target. As I'd mentioned before as well, this also serves as the mechanism to create our thin provision volume, to where basically you're able to go ahead and allot an amount of space or create an Iscuzzy device that's a certain amount of space, but the space that's required for the volume to store the information that's been placed on it is actually consumed at the physical level. So, we'll create a 2 terabyte virtual storage device that's thin provisioned, and if you've only got half a terabyte in there, that's all that's going to be consumed on the physical volume within the StarWind box. So, a very, very handy feature when it comes to being able to make sure that you're utilizing storage as efficiently as you possibly can. A scenario here might be, we always get, as IT folks, we always get specifications around how much storage an application owner thinks they're going to need. And then they ultimately only use, a fraction of that. So if we want to go ahead and use things like thin provisioning to go out and say, okay, well, I've given you your 2 terabytes, you really haven't had to give that 2 terabytes up just yet. And so you can manage around that and basically go ahead and it'll just consume what's needed from a physical perspective. So the potential there is to be able to oversubscribe a set of storage or a piece of storage if and when you need it to. So let me go ahead and bring it through and show you what creating one of these targets looks like so you can get a flavor for it. I'm going to start off with the basic virtual. Now, obviously, what we do here is we use, much like a lot of your VMs, this is basically going to create a piece of storage that's actually a file. So in this case here, I've got an image file device choice. RAM disk is actually an Iscuzzy target that's created in memory. This is a great little tool if you want to actually test the network connectivity between, say, one of your initiators and your storage boxes, because it eliminates the disk subsystem. But it's a nice little test piece. RAM disk is not something you're going to use, for the majority or anything, because obviously it disappears once, or the data disappears once the machine is turned off. In this case, we're going to use an image file device to go ahead and create our virtual storage device. Now, obviously, I'm given a couple of different options here. The mount existing virtual disk obviously is one of those things where these image file devices are persistent. The targets can be added and removed. but the image file device will persist until you delete it at the file level. So one of the things that this allows you to do is if you ever needed to, if you began to run out of space, if you've oversubscribed the disk from an I/O ops perspective, a physical set of disks that is, you could simply copy this image file over to a second or a third StarWind box and remount it. That's where the mount existing virtual disk comes in. We also allow you to create one of these basic virtual disks from a snapshot-enabled volume if you so chose. So you could certainly do that as well. This is nice if, let's say for a moment, the test and dev team needs a copy of, the latest copy of the production data. They can go ahead and create one of these image file devices from the last snapshot, mount that as an Iscuzzy target, and start utilizing that data without impacting what's in production. So, another nice option there, feature. We're going to create a new virtual disk, for the purposes of our demo. Now, the next thing we need to do is we need to go through the process of actually telling StarWind where should we house this piece of virtual storage. So what physical storage asset do I want to assign this virtual storage device to? In which case here, the virtual disk location and name, if I just click on the file browser here, I'll be able to get to it pretty quickly. So as you can see here, here are the physical volumes that have been presented to Windows in this storage box. So I can simply come in here and choose one and then go through and choose a directory that I want to keep this in. And we'll call this. Now, a couple of other things. We offer the ability to, now obviously you're going to size the disk, right? So this is the other critical factor here. I'm going to go ahead and size this volume, and I'm just going to create a small, 1 gig volume. Basically, you're going to create that, and it's going to go out and create a file that's that size. So this basic image file, this basic storage device, is going to be provisioned at the time of creation. A couple of other options that you have here, you can compress this. So one of the things you can do is you can set this file up for compression, and we'll leverage NTFS-based compression in this box to go ahead and compress this image file, or compress the data that's in this file wherever we can. So this is another sort of savings. So, and this is, not recommended for your high performance because it does create some overhead. However, for your bulk storage, for your archival storage, for your backup storage, you can go ahead and compress these volumes and really sort of get the most out of it. The other option we give you is encryption. So if you choose to encrypt the volume, you can go ahead and set up a user account, and it's going to leverage user accounts on the box to go ahead and protect this volume, so that if someone were to unmount it and try and mount it somewhere else, they're going to be prompted for this username and password. And as an additional security feature, when you select encryption, we also select fill with zeros. Now, fill with zeros is also an option that you can select as a standalone. Fill with zeros simply goes through and provisions and basically does exactly that. Fills the entire volume that the virtual volume that you're creating with zeros. Slightly better performance, but also creates a lot of overhead when it comes to setting up the device. So it's something that, unless this also is from a security perspective, much more secure. So it's something to consider when you're going about creating your virtual storage device. Now, a couple of other options here. Obviously, we mount by default in asynchronous mode. This means that this is, basically non-blocking I/O. So basically, we're going to allow, parallelism in the I/O that's associated with this device. Read-only mode, again, that would be if you, wanted to mount a given device just to be able to go ahead and pull data off of it. So maybe you want to mount an existing image file, but you don't want anyone to be able to edit it. You just want them to be able to grab information off of it. Allow multiple concurrent Iscuzzy connections. This is an option that, for those of you that are creating a resource cluster in your virtualization environment, or creating a SQL Server cluster where you're going to allow multiple concurrent connections, but there'll be a cluster service or some type of clustering in VMware. It's actually, you'll be formatting it with VMFS, which is a clustered file system, but something that will be controlling the write locks. You can never have multiple initiators connecting to the same NTFS volume outside of a cluster. And so this option is very powerful, but also you want to make sure that this is also a security issue as well. You know, if you want to lock down a piece of storage and you only want one initiator connecting to it, we've got a bunch of different ways you can do that between CHAP and access rights and you know, all the different security options. But this is one of the most fundamental, because this ensures that once you've got that initiator that's supposed to connect to it, connected to it, nobody else can connect to it. So this is you know, an option that you want to undertake on an as-needed basis. Now, the next thing I want to talk a little bit about is caching. Now, caching is available in all of the devices that we offer. What caching does is it allows you to, on a per-target basis, assign physical RAM in the box. So, you know, if you've got, you know, between 4 and 8 gigs of RAM, you can assign bits of RAM to individual Iscuzzy targets. And what that does is, as I/O is being moved down from the initiator, hits the network stack on the machine itself and is unpacked, that then needs to be delivered to the disk subsystem. Well, if the disk subsystem is busy, slow, overwhelmed, whatever the case might be, it's going to create some performance problems. It's going to create some delays. With caching, what we're going to do is we're going to actually allow you to write that data to memory. Basically, this I/O will be dropped off in memory and then basically reported back to the initiator as committed. The smart cache within StarWind will manage basically getting that data from the memory down to the physical disk. You know, and basically your block expiry period here sets how long a particular data block resides in cache before it's eligible to be written to disk. You can bump this up if you want to assign a larger cache, bump the block expiry period up if you've got you know, a lot of read-write going. So that way you can get some read caching going as well. Now you've got two types of cache. You've got write-back caching and write-through caching. The difference between the two, write-back caching, very simply takes the I/O, the data block, sticks it in memory, reports it back to the initiator as committed, and relies on StarWind to go ahead and go through the process of getting it down. The problem with this, obviously, is, and the danger here is if you have a large write-back cache and you suddenly lose power to your box, there's the potential for data corruption. So you want to make sure that any time you're using this type of cache, you protect that box with a very simple, you know, uninterruptible power supply with some power chute technology that will make sure that the box gets shut down elegantly. Shutting the box down elegantly ensures that the cache is flushed, and then ultimately brings the box down elegantly from there. So the write-through caching is going to write the data simultaneously to both memory and to the disk. This is obviously going to be a little slower than the write-back caching, but gives you the benefit if you've got you know, maybe a 60-40 or a 75-25 ratio where, you know, there's a lot of read going on of recent data that's been written. You can serve that up via the cache using the write-through caching. So a number of different options when you choose caching there. And then ultimately you're going to go ahead and finish up by creating your target. And that's going to ultimately create this target here that can then be connected to via the Iscuzzy initiator. So, you know, I can come over and I can start the process of, you know, connecting to storage via the, in this case here, the Microsoft Iscuzzy initiator, where I'm simply going ahead and discovering targets based on plugging in the IP address of my StarWind boxes. Now that IP, I could, you know, we do support multipathing, so if you've got multiple NICs that are associated with that box, you can put those in here. But ultimately, at its very base level, regardless of the type of target I create, whether it be a mirrored target where I'm connecting to my active node, a basic target like you just saw here, or a snapshot-enabled volume, it doesn't matter. As long as I plug in the IP address here of my target server, I then get presented with all of the targets that are available and eligible to be connected to. Once I've connected to one of these targets, I simply then go into disk management and treat it like just another volume. So again, you know, using Iscuzzy to go ahead and go through the process of serving up that disk and creating that central storage pool is very, very simple. Now, a couple of other things that I always like to mention, and if you need more information on this, that's what we're here for. We're here to help. So I want to touch on things like securing your storage, so things like CHAP permissions. You know, I'm able to go through the process of actually setting up a CHAP permission where I can go through and set basically a username and password. We're going to require authentication from the initiator side. So if I need to lock down a piece of storage, or I want to make sure that a piece of storage simply can't be connected to by just anybody, I could certainly do that, and I could add in the CHAP authentication information, so CHAP name, target secret, and then if I want to do bidirectional CHAP, so I want to have a bidirectional setup going here to add some more enhanced security, I can set an initiator CHAP name and secret as well. Same thing with access rights. So access rights basically allow me to go through and say, okay, this particular source NIC, which is you know, say a box that is going to connect to my SQL Server 1, can connect to these 3 targets, but cannot connect to, you know, these 4 targets. So this is just another way to either grant or deny access to individual targets based on initiators. And so as you can see here, you know, the source is 205, and the destination is, you know, if the destination, if the initiator is coming from this IP and it's trying to connect to these targets, it will deny that connection. So again, we're giving you the ability to lock down this storage from a couple of different angles, and you know, whether it be encrypting the image file or using CHAP authentication or using access rights, you really have a lot of options around security in terms of securing your storage and making sure that, you know, no one's inadvertently or, you know, nefariously connecting to pieces of storage that you've created that are out on your network. So that's kind of the presentation that I've put together for today. I want to put up some contact information for everybody. You know, if you're interested, if you're, you know, somebody that's new to Iscuzzy, or, you know, if you're somebody that's recently purchased and wants to just sort of bounce some ideas off of us, let us know. You can contact us here at this number. We're happy to help in any way that we can in terms of, you know, aiding you in terms of getting a project like this off the ground. If you have any questions at all, I encourage you to go ahead and type them directly into the user interface there. We're more than happy to answer them. If for some reason, you know, you don't, you know, want to ask your question in this forum, certainly feel free to contact us directly, and we'll set up a one-on-one session where we can discuss your situation in a little bit more detail and make sure that, you know, you've got a thorough understanding of what's happening before you go into this. So let me see if there are any questions out there, and if there are, then we'll move on. Okay, so the first question we have is, so this runs on top of Windows, no bare metal option. That is correct. Under the current setup, guys, we run under Windows. So basically, we're gonna serve up as a Windows application. One of the things we are working on, for those of you that are interested, is to go through and we're going to be setting up a virtual storage appliance where we're basically porting our Iscuzzy target to a flavor of Linux that would be able to be installed in a virtual environment and basically leverage the local storage in that particular virtualization box. What's the preferred Mac Iscuzzy client? Carlos, there's a couple of them out there. I don't remember it off the top of my head. There's really one out there that really works well. I believe it's ATTO. But Carlos, I'll send you an email with those. I've got those handy. I just don't have them in front of me, and we'll be able to go ahead and get you, you know, sort of what you need there. These slides will be made available, so anyone that's interested, you'll be getting an email follow-up. A couple of emails, one from me thanking you for coming to the session, and another one from our marketing group where you can go ahead and download this. And so we'll certainly get that out to you. Brent, you can, I'll shoot you a quick note, Brent. There's actually, you can sign up for our beta program. We're actually, we haven't released the virtual appliance yet. However, it should be out within the next, I'd say, 45 days, but we are going to be doing an active late-stage beta with it, so I'll certainly get those details out to you. Is it possible to have primary, secondary and then a disaster recovery site, so a third site. So basically go from 1 to 2 to 3. There's a couple of ways to do that, Greg, and you know, I think we should probably talk about it. I'll shoot you a quick note with my contact information. Under the way the code's currently constructed, it's really designed for a 2-node setup. However, there are a couple of workarounds where you can go ahead, and they are supported workarounds, but admittedly they're workarounds nonetheless where you can add a third node. And I'll shoot you out some information on that as quick as I can. All right, guys. Well, listen, we're just about at the hour mark. I'll leave the GoToMeeting open for the next 5 to 10 minutes, so in case you do have questions that you want to ask, don't be shy. Like I said, I have recorded this session, so you guys will all get a copy of this. I really appreciate you coming out. You know, we're really excited about what we're doing. As you can tell, we're a group of people that are very passionate about Iscuzzy. You know, we've got a number of different events that are coming up, so I invite you to hit the events page. You know, we do a couple of events that, you know, on a weekly basis. One of them is a Getting Started, where we actually bring you through some of our more high availability offerings, so we'd encourage you to go there as well. Again, I appreciate everyone's time this afternoon, and we'll look forward to hearing from you all soon. Thank you.